Okay, so I'm just going to record today's stuff. So if you do want to go back and look at it, you can. Today, what we are doing. So hopefully, yesterday you took the quiz, right? So I hope everyone took the quiz yesterday. Did the STAR assessment. I'll be kind of looking over that later on today, grading you on that. It's actually pretty easy to grade that one. Okay, so just make sure you've done that already. All right. I'm trying to see if everyone did it, but it's not. It's going really slow. Okay, well, whatever's. Doesn't matter. Okay, what we're doing today, we're going to talk about two different things. First, we're going to talk about scientific notation. And then after we talk about scientific notation, we're going to talk about converting units. So if you like, you can pull up both of these two worksheets here. Everyone's gotten a copy of these. Okay, if you want to pull them up on your computer, that might help. Otherwise, I'm going to be presenting them here, so you'll see it right here. So let's get started. Let's get right into it. Let's talk about scientific notation. Okay. So hopefully you've seen scientific notation before. If you haven't, that's okay. I'm going to explain what it is and how we do it. Okay. Basically, in science, it's common that we use very, very large and very, very small numbers. For example, like a red blood cell is 0.0065 centimeters. And the distance from the Earth to the Sun is 150 million kilometers. Okay. It's really annoying to write all those zeros all the time, right? So instead of writing all those zeros, we use something called scientific notation. And basically, scientific notation is a number between 1 and 10, not including 10, times a multiple of 10. Okay, that's basically what scientific notation is. All right. So today we're going to learn how to convert from regular numbers to scientific notation and from scientific notation to regular numbers. Okay. So I'm going to kind of skip over this explanation here. I'm not going to do it exactly as they're talking here. I'm just going to show you some examples. And I think the examples just really help. And you can fill out the answers to this stuff later on. All right, I'm not gonna walk you through all this. You can do those answers later. What we're gonna do is I'm just gonna write some examples and then give you some time to practice and then see if you have any questions. All right, this shouldn't take too long here. Okay, so here we start with 0.0065, so we're gonna look at this one first. 0.0065. So this number, if you want it to be in scientific notation, it has to be a number between 1 and 10 and times 10 to some power. Okay. So first of all, we look at this number, we look at it's 65, or we make it 6.5. Okay. Make the little thing a little smaller there. Bear with me for a second here. I'm just going to make this so it's a little bit easier for myself. Okay, we start with a regular number. So again, 6.5. And it's going to be times 10 to some power, right? And in order to figure what power this is, we just take, okay, so now we move the decimal here between the 6 and the 5, right? We just count how many spaces we need to move that decimal. So we need to move it 1, 2, 3. We need to move it 3 spaces. Sorry, my computer's kind of messed up at this one section here. Okay. However, so we moved it 3 spaces. However, this number was less than 1. So anytime the number is less than 1, anytime it's a decimal, the exponent is going to be negative. Okay, the exponent is going to be negative. So again, we take the number, we take it, and we put the decimal so that it's a number between 1 and 10, so 6.5. Okay? And then however many spaces we need to move, so 1, 2, 3, we need to move 3 spaces, that's the exponent. And then if the number is less than 1, we make it negative 3. We make it negative. If the number is larger than 1, it's positive. Okay? So the same thing here. We have 150 million kilometers, right? So in order to make this a number between 1 and 5 or 1 and 10, we make it 1.5. So it's 1.5 times 10 to some power, and the power again is however many decimal places we had to move. So this one we had to move it 1, 2, 3, 4, 5, 6, 7, 8. We had to move it 8 decimal places. Okay. Now this number was larger than 1 to begin with. So that means it's a positive exponent. Okay, pretty simple. Not too bad, right? Should have given you more decimal practice. You only want 2 more. It's okay. Okay, take a minute and try these ones that I gave you here. Okay, I'm going to pause for a couple minutes and try the ones that are here. You can write it on a separate sheet of paper for now. That's fine. Okay, so even if you're not done, just stop for a second. I'm going to go over some of these. I'm not, maybe not finish all of them, but okay, so the first one here, or the next one, we have 334, whatever that number is. So the decimal is going to go between this 3 and 3. So we're going to get 3.34 times 10. And then the decimal again for a whole number is always at the end here. So there's the decimal. And how many spaces has it got to move? Well, you got to move it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Ooh, 10 to the 16th. Hopefully I counted that correctly. The number is larger than 1, so it's a positive. So it's positive. Okay, next one, 1,350, so 1.35 times 10, and we got to move the decimal 1, 2, 3 to the third. This one here, the decimal is going to be moved between the 3 and the 5, so 3.5. And we have to move it 2 places. So times 10 to the negative 2, because this number is less than 1. It's a decimal. So if it's less than 1 in a decimal, then it's a negative. Okay, next one, we have to move it between there. So 1.004, and we moved it 1, 2, 3. Next, 135, 1.35, 1, 2, 3. It's the messed up part of my screen. 34 is going to be 3.4, and then it's just 1. So times 10 to the first. This one, 1.0, and then 1, 2, 3, 4, 5, 6. 2.66 times 10 to the 1, 2. 3.04 times 10 to the 1, 2, 3, 4. Negative 4 because it's less than 1. Then 230, 2.3, 1, 2 times 10 to the second. Got it? Easy peasy, no problems. Okay, let's go the opposite way. Opposite way is a little bit trickier. Probably should have gave you more examples here. But basically, you're just going backwards, right? Now, we're going to be moving the decimal, this number of spaces, and we're going to move in the direction to make it either decimal or a bigger number. So I don't like to think left or right. I don't know why. I just don't like that thought. I think if I move the decimal if it's negative, I have to move the decimal so that it becomes a decimal. If it's negative, it's a decimal. So here, 6.23 times 10 to the negative third. So 6.23 times 10 to the negative third. So we have here, we start with 6.23. And we're going to have to move this decimal 3 places. Because this is negative 3, we're going to move it so it becomes this becomes a number less than 1. So we're going to move it this way. 1, 2, 3. So here's the decimal. And then anywhere I have those little loops, I just put zeros. 0, 0. So there's my answer. 0.00623. And typically we put a 0 in front as a placeholder. But you don't have to. Okay, and then this one here, 6.23. And it's times 10 to the 5th. This is a positive, so it's going to get bigger than 1. So I have to move the decimal so that the number gets bigger. So move it to the right. 1, 2, 3, 4, 5. And then all these little loops, 1, 2, 3, I fill in zeros. So 6, 2, 3, 1, 2, 3. Okay. Okay, try the other 3 real quick. Okay, let's go to the next one. So 3.004 times 10 to the 7th. So we're going to move it 7 spaces. It's a positive 7, so it's going to get bigger. So we're going to move it 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4. 4.5 times 10 to the negative 5th, so 4.5. And then I got to move it 5 spaces, and it's negative. So we're going to move it 1, 2, 3, 4, 5. And then I got to fill all those in with zeros. 1, 2, 3, 4. So 0.1, 2, 3, 4. There we go. Then last one. And 1, 2, 3. There we go. Pretty simple, right? Okay, that's the easy part. You can answer those other questions later. All right. Gets a little trickier when we have to deal with scientific notation and significant figures, but we'll deal with that another day. Okay, let's move on to converting units. We're going to talk about converting units and everything except for temperature. Temperature and some other, there's other things in science too that are not going to be converted this way. But we're going to talk about something called dimensional analysis today and how to convert units using dimensional analysis. As soon as my computer catches up to where we are. Okay, first of all, I know that you guys are probably good at this, but sometimes when I teach this, people have trouble with fractions. So I always start off, because dimensional analysis deals with fractions, I always start off with a very brief lesson here on how to deal with fractions. So I'm just going to run through it really, really quick. I'm not even really going to do these problems. I'm just going to kind of talk through it real quick. Okay, so just remember when we're multiplying fractions, we have a numerator, denominator. The top number is the numerator, bottom number is the denominator. If we're multiplying two fractions, we always multiply the numerators times the numerators, denominators times the denominators, okay? And just move across that way. If there is a whole number is just like that number over 1, okay? So, for example, if we have 8, 8 is just like saying 8 over 1 because 8 divided by 1 is 8, so it's the same thing, okay? So if we have 8 times 2/3 times 4/5, we want to do this multiplication here. Then we just make 8 over 1. So 8 over 1 times 2 over 3 times 4 over 5. And we multiply the top numbers all across. So 8 times 2 times 4, we get 64. And then we multiply the bottom numbers, we get 1 times 3 times 5 is 15. And then we divide 64 divided by 15, and we get our answer. Okay, so just keep that in mind when we're doing dimensional analysis. Okay, I'm not even going to do these practice problems. I'm not even going to ask you to do them. It's fine. Okay, just remember that. So if you're multiplying, if you know how to multiply fractions, you can pretty much do any conversion, well, except for temperature. Temperature is a little bit different. Okay, and when we set up our work here, so let's say, for example, we have this problem. A piece of string is 320 centimeters long. How long is it in meters? Okay, I like to set it up this way. So we start with our given. We're multiplying times a conversion factor, and we'll get our answer. We should always make sure that we know that the numerator of one fraction, the units for the numerator, will cancel out or will be the same as the denominator for the conversion factor. Okay, so for example here, if we have 320 centimeters and we want to get meters, we put the relationship of meters to centimeters here because centimeters on top here, it's on bottom here. So they're always going to be opposite of one another. Okay, they're always going to be opposite of one another. The centimeters cancels with centimeters, so units cancel. It's not the numbers that are canceling, it's the units. Okay, and then you multiply across. And the relationship between meters and centimeters, you could either have that 0.01 meters is 1 centimeter, or you could have that 1 meter is 100 centimeters. It's the same thing. It's the same thing. Doesn't matter. Okay, I don't know why I put 0.01 there. I typically do 100 centimeters. I usually do 1 meter over 100 centimeters. Okay. Okay, so a little bit here, like you always on the top is what you want, and on the bottom is what you want to get rid of for any conversion factor. So one-step conversions are pretty simple because we just put the units that we want on top, units what we want to get rid of on bottom. It gets a little bit trickier when we have multiple steps. Okay. So I'm going to do, let's see here, liters to quarts. These are all, okay. I'm going to skip down to like number 6 here. Okay. So one of the things, when you guys show your work on this, I want to see the work when you do the problems here. And what I mean when I say I want to see the work is this is what I want to see. I want to see what you start with. And I'm actually going to, I should show you how to do this on the, let's do it on the other thing. Give me 1 minute here. I'm gonna show you actually there's a way to do this in Google Docs that you can do if you like. I'm just gonna show you how to do it. But feel free to do this work on a separate sheet of paper and then just take a picture of it and upload it online. It's fine. Or you can even take a picture of it and and then paste it into the document, into the Google Doc. It'll open one of these days. Just going slow because I'm recording and doing the Google Meet, using a lot of different programs. Okay, here we go. Okay, let's do one that involves multiple steps here. So the first few just involve one step, okay? I want to show you how to do some multiple step one. We could do one, I guess. We could do one. Oh my goodness, so slow, it's killing me. Reminds me of when I first started on the internet. Just like when the internet first came out, we had 28K modems. Super slow. Come on, come on. All right, well, while that's trying to figure itself out, maybe this will work better. Okay, so let's just look at a really simple conversion. Let's go decigrams to grams. Okay. So we have 30 decigrams to start with. And we want to convert it to grams. So if you're doing this on a sheet of paper, what I want to see is I want to see these brackets like this. Okay. So instead of writing like the multiplication sign, we just draw brackets instead. Okay, this indicates that we're going to be multiplying. It's just creating a conversion factor here. Okay, so brackets. And then we want to get rid of decigrams, so decigrams goes on the bottom, and then grams goes on the top. Okay, now I don't like to deal with decimals here, so I just say like, well, 1 decigram. Sorry, 1 gram is 10 decigrams. Okay, 1 gram is 10 decigrams. So again, you could have 0.1 grams is 1 decigram, but I don't like using the decimals. So here's your conversion factor, this 1 gram for every 10 decigrams. Okay, you could put this over 1 if you want, but you don't have to. So you could put the 30 over 1 if you want to, but you don't really need to. So then you go 30 decigrams times 1 is 30, divided by 10 is 3. And then decigrams cancels with decigrams, so you wind up with grams in the end. Okay? So make sure for your answers you have units, and then you circle or box your answers. Okay? So a couple things. Make sure that your answer has units. So units are important in your answer. Okay, circle or box your answer. And when you do your work, show the brackets like this. So let's look at another example here, number 6. We have 34 millimeters. And we're going to kilometers. Now, we can find the relationship between kilometers and millimeters, but I often find that kind of difficult. Okay, it's kind of tricky. So what I'm going to do first is I'm going to go through the base unit. I'm going to go to the base unit. The base unit for meters is meters. Millimeters, kilometers, it's meters, right? So I'm going to go to meters first. So meters goes on top and millimeters goes on bottom. Then once I have meters, now I have meters, I want to get rid of meters, so meters goes on bottom here. And then I want to get kilometers, so kilometers goes up here. And now the relationship between these two things are pretty, we kind of know. Okay, if you're not familiar with what milli means, deci, kilo, all that stuff, then get yourself familiar with it. Okay, get yourself familiar with it because you need to know those things. Okay, 1 meter is 1,000 millimeters, and then 1 kilometer is 1,000 meters. Okay, so again, I put my 2 conversion factors in brackets here. I use my base unit meters as kind of an intermediate to help myself go from one to another. Okay, and then I multiply the tops, 34 times 1 times 1, and then divided by 1,000 and divided by 1,000. Now, it comes out to this number, 0.000034. And if we look here, millimeters and millimeters cancel. Meters and meters cancel, and we wind up with kilometers in the end. So the units are kilometers. Okay, another way to do this is to use scientific notation because this is a really big number, right? So we can make this 3.4 times 10 to the 1, 2, 3, 4, 5 to the negative fifth. Okay, let's look at and we'll talk about 14 later. Oh, actually, let's do this one. So number 13 and 14 are a little bit challenging. '13 and 14 are very similar. So what we have here in number 13 and 14, so number 13, a bus driver drives 43 miles per hour. So 43 miles for every 1 hour. We want to know how fast does she drive in kilometers. Oh, that was easy. This one's kind of easy. Kilometers per hour. Okay. So this one we're just converting miles. Actually, the number 14 is a little bit trickier because we're actually converting the pounds to kilograms, and we're also converting minutes to hours. Okay, we're doing we're converting 2 different things. Okay. So this one's a little bit tricky. It's a little bit hard. Let's do 13 first, and then we'll actually do 14 too. And I'll just give you, you're going to get some more practice with this tomorrow. So, okay, so 43 miles per hour, we're going to go to kilometers per hour. So this one we have 2 units. We're not really going to be concerned about the hours, though. We want to get rid of this miles. So miles on bottom, and kilometers on top. Okay, we want to get rid of miles, put kilometers on top. So here, I believe it's 1.6 kilometers per mile. Let me just double check. Well, they have 1 kilometer is 0.62 miles. Okay, we'll use that, sure. I'm pretty sure it's 1.6, but we'll use 0.62. So 1 kilometer is 0.62 miles. So we're going to do 43 divided by 0.62. And we get 69, basically 69 kilometers. Again, use the brackets here. Okay, makes it much easier when we have longer problems. Okay, this is just the beginning of this. Okay, and then 43 divided by 0.62, you get 69, and miles cancels, and we get actually 69 kilometers per hour. I forgot the hour part. So don't forget the hour part. Okay. Now we have something like 14. So 14, we start with 12 pounds of groceries for every minute. And we want to convert to kilograms per hour. So we got to pick which one we want to do first. And it doesn't really matter. I can convert pounds first or minutes first. Let's start with minutes. So let's minutes to hours. So I want to get rid of minutes, so I put them opposite of one another. So minutes, and I want to get hours down here instead. And we know that the relationship here between minutes and hours is there's 60 minutes and 1 hour. 60 minutes and 1 hour. So that will convert our minutes to hours. Next, we got to convert pounds to kilograms. So pounds on the bottom here, it's opposite. And then we want kilograms up here. And I believe it's 2.2 pounds per kilogram, but let's make sure. I bet you it's 2.2 pounds per kilogram. So 2.2 pounds for every 1 kilogram. Okay, and you'll see that the minutes will cancel with minutes because they're opposite. Pounds cancel with pounds because they're opposite. We wind up with kilograms and hours. Then it's a matter of multiplying. 12 times 60 divided by 2.2. And we get 327. And that would be 327 kilograms for every 1 hour. Okay, so make sure you include units and then circle or box your answer. I know, a lot to take in here. Okay? So again, use the brackets, show all your work, circle or box your answer, make sure you include units. Okay, again, you can write it on a separate sheet of paper, and I'm going to attempt to show you how to type it in if you want to type it in. We'll see in a second. There was one more thing I wanted to say. Oh, yes. If your numbers are really, really big. So typically, I get the question, well, when do we use scientific notation? Okay, when do we use scientific notation? Typically, I see scientific notation used and accepted if the number is less than 1,000. So the number is less than 1,000. So if you have anything in the hundreds, typically we don't use scientific notation. Anything larger than the the 100, so we get into 1,000, then we'll use scientific notation. So we'll use like 10 to the third. Okay. However, I'm not that picky. If you have a number that's 2,000 or 23,000, that's okay. But if you have something like like 23 and it's like this many zeros, don't write it like that. Write it in scientific notation, please. So if it's a really, really big number, you want it in scientific notation. Same goes for if it's a really, really small number. So if it's more than 3 decimal places, typically if it's more than 2 decimal places, so if it's 0.00, if you have 2 zeros, then you want to use scientific notation. Okay, so if you have like 0.00000, use scientific notation. Anything more than 2 zeros or more, so 2 decimal places or more, use scientific notation. Okay, I don't really want to see answers like 0.00000000075, right? That's really annoying. It's not a good way to write your answers. This should be like 7.5 times 10 to the 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Again, I'm not that picky, and I probably won't mark you off if you get the right answer. Even if you wrote it like this, I probably wouldn't mark you off, but I might write a little note saying, hey, come on, write scientific notation. Okay. Whew, so last thing, let's see if I can get this to work before you go. Let me just show you how to do this. Let's do it for this one. Come on. Are you going to work today? It moved. Let's see, it might work. Okay, so there is a way to do this. So let's say we start with 10 liters, where you can type it in. Oh, it's working sort of slowly. So if we start with 10 liters and we want to go to quarts, there is a way to show the work on here. And again, this is totally up to you. You can write out the work. But what you do is you go to Insert. So click on Insert here. And then we're going to insert an equation. So we go down, Equation, Insert Equation. And then when we go to Insert Equation, a little toolbar is going to pop up. So here you see a little toolbar and it'll say New Equation. So we want to click on that new equation, or really it'll be there. And the first thing I always do is, again, because we're using the brackets, is I go to this little guy right here and I insert some brackets. So here, just go, I like using these ones, but not these ones, just the 2 bars. Okay, you can use any really brackets, I don't care. Okay, any of these 4, there's 4 different types of brackets here. Doesn't really matter to me. If you think one's prettier than the other, you can use the pretty one. I don't care. Okay, but I like using these ones, so click on that. So now that I have the brackets, I can now put a conversion in there. So in order to do a fraction, I click on the same area, and then it's the first one here, fraction. Okay, and then on top goes our what we want to get. So we do quarts. So this one, 1 quart. I'm looking at the conversion up here. 1 quart is 0.946 liters. So 1 quart on the top, and then on bottom, 0.946 liters. We just have a little bit of a delay here. Sure, it's driving you guys as crazy as driving me, if not more. Okay, so there, look, now we have the conversion factor in there. Although I spelled liters, I accidentally hit U. And then you just say equal, and then you can put your answer. Okay? Oh. Okay, anyway. Yeah, so you can do it that way too. You can type it in that way. All right? Whew. All right. That was a struggle today. All this slow running technology here took us 50 minutes when it really should have taken us like 30. Okay, anyway, that's it. I'm done. You guys can finish the work and the rest of the time that is given to you in class here. You don't need to stay logged on. You guys can take off if you want to. Just make sure you finish those 2 assignments and turn them in by tomorrow, okay? I'm going to stick around. If anyone has any questions, I can answer any questions. If you get stuck on a problem or something like that, then I can help you out. Yeah, round your answers, 3 significant figures, so 3 numbers basically. Okay, typically 3 sig figs is good for most things. We'll talk about sig figs and how to deal with them a little bit later. Okay, and tomorrow we do not have class. Tomorrow, I'm actually going to post the assignment for tomorrow right when I sign off here, and it's going to be basically more work on more practice on this. So not sig figs, scientific notation and conversions. Okay. So not necessarily to the thousands place. So you want to round to 3 digits. So 3 digits. So if it's 0.00364587, you want to make it 0.003645 and end there. So 3 numbers. 3 significant numbers. Does that make sense? So the answer is like 0.3655555555. You could do 3.66 or 0.366.